Hey there, today we are finding rational zeros, and this is part 2 to this topic. So, in these types of problems, your directions are going to be to find all the real zeros of the function. So, you're going to get a problem like this. Example 1. F of x equals 2x to the third plus 4x squared minus 2x minus 4. Now, previously we've talked about synthetic division, and we could use synthetic division to find the zeros. But let's go back a couple sections and talk about grouping. Now I have 4 terms, and if I just kind of look at these and say, can I get a GCF after I group them? Well, let's try it. So just a little reminder on what factoring by grouping is. Now remember, we want to factor or create 2 groups here. So we have 2x to the third plus 4x squared plus, and remember that negative is going to go with that, negative 2x minus 4. And now I factor out a GCF between each of the groups. They each have their own GCF. So in this first group, I have 2x squared as my GCF, so I'm left with x plus 2. If I look at my second group, my GCF is a negative 2. So I end up with x plus 2, because negative 4 divided by negative 2 is negative 2. Alright, lastly, I'm going to factor out a new GCF. So both of these terms have an x plus 2. So x plus 2 is my new GCF, and I'm left with 2x squared minus 2. So this equals f of x still. But let's take a look at this. I'm not sure I really like this 2x squared minus 2 because I see another GCF in there. So if I change that to 2 times x squared minus 1 and still multiply that by x plus 2, now it looks a little bit better. Because if you look at x squared minus 1, that is a difference of 2 squares. So f of x equals 2 times x plus 1, x minus 1, and then we still have that x plus 2. So not until now is this fully factored. So now I can find the zeros. If I set this equal to 0, I can then set each factor equal to 0. So x plus 1 equals 0, x minus 1 equals 0, and x plus 2 equals 0. So my zeros are 1, negative 1, and 0. Those are the zeros of the given function. But unfortunately, not every polynomial can be factored by grouping. So that's why we learned synthetic division. So if I wanted to use synthetic division to do a problem like this is what I would do. Remember that the directions are to find all zeros. So my function is f of x equals x to the third minus 8x squared minus 23x plus 30. We need to find all the zeros. Well, this is step 1. Use calculator to find only one zero. So we're going to use our calculator to get us started. So I don't have to go through and guess and do all these extra work when I have this cool calculator I can use. So I'm going to show you here on this big screen. So y equals, and we need to type in our function, x to the third minus 8x squared minus 23x plus 30. And I can look at the graph. So remember, the zeros are where the x is crossing the x-axis. So here I see 2. But remember, you can only use your calculator to find 1. So second calc, go to 0. Remember, we're doing left bound and right bound. So I need to get my cursor so it's on the left side of my 0. Enter. Right bound, so it jumps to the other side of the line. Press enter. And then press enter one more time, and we get our 0. So here, it tells me right at the bottom of the screen, x equals 1, 0. So I know that x equals 1 is a 0. And since I know that, I can use synthetic division to find the rest, to factor it to find the rest. So my coefficients are 1, -8, -23, and 30. Make my line. Bring down my first number, 1. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. And -23 plus -7 is -30. And then 1 times -30 is -30, and my remainder is 0, which is good, because I already knew that 1 was a 0. So what this means is, if x equals 1 is a 0, then x minus 1 is a factor. So when I rewrite f of x as this, I get f of x equals, my first factor was x minus 1, and then the rest is my numbers. After we divide by that factor, we have x squared minus 7x minus 30. Then the last thing I need to do is try to factor this second trinomial just a little bit more. So my first factor is still x minus 1. And then I need to use my guess and check method to find two numbers that multiply to 30 and add the 7. Well, 10 and 3 multiply to 30. And if I do negative positive, I have -10 plus 3, which gives me -7. So fully factored, this is my polynomial. Now I just need to set each factor equal to 0, because that's what I'm looking for. I'm looking for the zeros, or sometimes we call them solutions. So x equals 1, x equals 10, and x equals -3. Those are the three solutions to our polynomial. So what you've seen today is me use synthetic division to find all the zeros of the function. First, I found one of the zeros on my calculator. Remember, only one on the calculator. Then I used that 0 to plug in for synthetic division to find the rest of my polynomial, right? Once I divide my original polynomial by x minus 1, what I have left is x squared minus 7x minus 30. And from there, I can find my solutions. So if you're still a little lost, please rewind, rewatch. And if you need to, rewatch the calculator portion so you know exactly how to find the 0 when you get to class tomorrow. See you then.